Everybody, we are continuing on with similar triangles. Today's going to be one of many, well, a few theorems we're going to learn. So we're learning angle, angle, similar. So all that means is if you have two similar triangles and you know one angle is congruent to its matching corresponding angle in a different triangle, and it happens twice, the third angles would have to be congruent because all three have to add up to 180. So I know if you have two pairs of matching congruent angles in two corresponding triangles, those triangles are similar by what we call angle, angle, similar. Okay, so you're saying, yes, that's one theorem, angle, angle, similar. One triangle has a match. You don't need that third one because it has to be, because we know three angles add up to 180. This is saying the same exact thing, and it's called angle, angle, similarity, but we just say angle, angle, similar in shorthand. So one thing I want to show you here is if I line these up, it's kind of cool if I can get it to do it. Okay, to start, okay. Okay, you can see there's a shared angle and the bottom lines are parallel. So it's supposed to line up on top of each other. So this is angle, angle, similar, because if this line here is parallel to this line, we have this angle being a shared angle in both triangles, this angle congruent to this angle, and the third, but we only really need two. So I usually pick the shared angle and one of the others. This only works for parallel, or these two lines in red are parallel and there's a shared angle. Then for this type of problem, all you're going to do is you're going to go, okay, let's find the missing angle measure, knowing they add up to 180. So I know angle A would be 80 degrees. Okay, and I know since all three have to add up to 180, I know this is 58 degrees. So we could say, now you got to make the similarity statement, triangle, and I pick any one I want to start. So say I have triangle cap is similar to triangle. Now I did cab 58 degrees, 80 degrees, 42 degrees. So I have to do 58 degrees, 80 degrees, 42 degrees. So I do the first three and I have to do it in matching order with matching degrees. Okay, now this one, because these are parallel, I know these angles are congruent and these angles are congruent. That's just something I wanted to point out. So we could say angle Q is congruent to angle N. Angle P is congruent to angle M. And I know we have our vertical angles here. So I know, and this time, because we don't know which angle X, we would have to say angle QXP is congruent to angle NXM. So then you make a similarity statement. Triangle QPX, oops, that's an X. See how we're going QPX in order? Is congruent to triangle NMX, NMX, that's an X, by angle, angle, similar. That's how we kind of state the similarity statement. We will have more theorems. So again, see if they add up to 180. If they don't, can you find the missing angle measures? Then can you write a similarity statement? So I could have written it in a different order. I could have written it DEC or EDC, but the second triangle is orders determined by the first triangle. And then for today only, it's because of angle, angle, similar. Again, so you're going to go, do they have matching angle measures? Well, I subtract from 180 and I get a 15 degrees and I get a 75 degrees. So then again, triangle, if I want to say ABC, and it's not a congruent, I'm glad I actually did that because sometimes you get on autopilot. So I did 90, 15, 75. I'm going to have to do 90, 15, 75. This one, I figure out if I do 180 minus 16 minus 30, this gives me 34 degrees. There's not a 34 on that degree angle on that one, so they are not similar. Okay, remember if these, they have this shared angle here, so, and this angle here, so I know triangle ABE is similar to triangle ACD by angle, similar. Because it's a shared angle to 52, shared angle to 52, shared angle to 52. This is the same as that other one. Again, those two are congruent because of those parallel lines. We'll talk a little more about that. But again, you pick your first triangle. Again, it doesn't have to be in any specific order, but the second order is dependent on the first order. Same thing here. So again, you're just rewriting them over and over and over. So we have the shared angle. So we have triangle, and because these are parallel, I know those two are also congruent. So I would say triangle, the small one, CDB, is similar to triangle CEA by angle, similar. Again, I could write them in a different order if I wanted BDC, then it would be AEC, and then the rest would be the same. Okay. Okay, write a similarity statement. Well, those are two congruent triangles, so you're just going to say, basically, give me a pair of angles that are congruent, give me another pair of angles congruent, give me a similarity statement, and say it's because of angle, similar. Same thing over here, okay? Here we go. So again, give me a pair, find the missing angle measures, then tell me which match up. Obviously, we have some 90-degree angles here because of a straight line, so we know they must be 90 degrees. So tell me two pairs of angles that are congruent. Then this is a similarity statement by angle, similar. Don't worry about this one. Okay, we're going to skip this problem right now. And then for this one, all you're going to do is you're going to draw two triangles. And we're going to label them. And we're not going to worry too much if they are actually drawn to scale. And we're going to start labeling. So angle H is 100 degrees. Angle K is 46 degrees. So then I know 180 minus 100 minus 46, that's got to be 34 degrees. Now I go, angle P is 44 degrees, angle Q is 46 degrees, and I go back to that 180 minus 44 minus 46, and that's got to be 90 degrees. So you can see they're not drawn to scale. Are they similar? No. Why? Because there's no angles that actually have a corresponding congruent angle. But drawing the picture does help and would help if they were congruent in writing the similarity statement. Okay, here you go. If you have questions, let me know. Tomorrow's going to be a short formative on yesterday's and today's stuff. Have a great day.